this is an example of how to determine if a situation is linear or exponential. The following table shows the number of compact cars in a country over the course of several years. Our years go from 1981 all the way up to 2008, and our number of cars starts at 100 and go all the way up to 10,910. So in order to figure out any type of regression, these values in the years here, these values are too high. It's going to overflow the calculator. So we actually need to pick a starting point that is not any of these years, but numbers that are significantly smaller. So the first thing we're going to do is kind of add another row right above this year row that we're going to use as our x's, and we're just going to say that's years since 1980. And then these values we will put in as our x values for the regression. So once we have those values, we want to put all of the data into our calculator. So here we have the calculator, and if you have information in your lists, remember you do not want to delete, because if you go up to L1 and you push delete, it totally just gets rid of it. But all of your data is still stored there. So in order to clear out information, you want to push clear and then enter. And then in order to get your list back, you come up to Stat and you push Setup Editor. Click number 5, and that will give you all of your lists back, starting with list 1 and any other list that you have deleted, especially if you start with list 3 or list 4. So our list 1 is going to be the years since 1980. And then in list 2, these are going to be the number of cars in those years. And I'm pulling all this data from the table in the problem. And then what I want to do is try and look at a scatter plot. So I take a look at my values in L1. I'm going from 1 to 28. So my x's should maybe go from -1 up to, say, 30. And counting by 1s might be a little much, so I'll count by 2s. And then in my number of cars, I go all the way from 100 all the way up to 10,900. So Y min should probably be 0. And then how about the Y max be 11,000? And counting by, I don't even think 100 is big enough. I would say counting by 1,000 is probably good. So now my window is all set up. Come into second stat plot. My first plot is on, so I'm good to go. I'm using list 1 and list 2. So I push graph. And here I have, oh, look at that. I not only have the dots, but I also have the line, because clearly I didn't delete it from before. So I'll clear this out, push graph again, and there I have the dots. Okay, so I have a really nice looking scatter plot, and it is quite obviously a curve, so I'm probably leaning towards more of exponential regression. So stat, calc, I'm going to run linear regression first, because you never know, maybe it's linear regression. Run linear regression, and my equation would have a rate of change of about 335, and my y-intercept would be negative 2,124, and my R value is 0.857. So it's a little on the low side for me to really be confident that that is, in fact, a linear relationship. Okay, so I have all that data recorded, so then I'm going to come back and run exponential regression, which remember is just option 0. And when I run exponential regression, I get an R value of 0.99. That's the first thing I went to. It is a definite exponential relationship. My starting value is 98.9, and then I have a growth rate or a common ratio or a percent increase of 1.182. So my percent increase is about 18.2, 18.3. Because remember, I take that 1.182, subtract 1 to get the decimal, and then multiply by 100 to get the percent. So my percent increase, I'm growing at a rate of about 18% each year of compact cars. So it's definitely a exponential relationship. So I'll go ahead and get rid of this linear stuff. And I'll start my sentence by saying the compact car is increasing at a rate of about 18.2%. And then using the regression equation, which if we forget, another way that you can find it, you do second enter and it goes into previous entries. So I can run regression again, and yeah, I ran different numbers earlier, so my regression equation that I recorded should actually have been 98.9. So I'll go ahead and fix that because right now I have 99.169. So 98.9. Okay, so 98.9 times 1.182. And then if I'm looking to figure out how many cars would be around in this country in the year 2035, I need to think about how far away 2035 is from 1980. So the year 2035 minus 1980, oh, not 19.8, just 1980, gives me an x value of 55. So I would be substituting 55 into the equation. So I would have 98, what was it? 98.9 times 1.182 raised to the 55, because I'm 55 years after 1980, and that gets me about 975,343 cars in the year 2035. So I'll just go ahead and write that sentence right here. And then the last thing that you can do is take a look at the graph one more time, and we had all these really nice dots. And then if you are interested in pasting the regression equation into your y equals and making it as exact as possible, when we run regression, we have lots and lots of decimal places in our A value and with our B value, all these decimal places. So in order to paste that in, you immediately run the regression, then you push y equals, come here to vars, and we are dealing with statistics, so we click 5. We want to come over here to EQ for equations. We want to paste a regression equation, so push enter, and it incorporates all those crazy decimals and then some. And then when we push graph, not only will we have the scatter plot, but then we will also have that really nice curve of best fit, so to speak.